Good evening, everyone. Good evening, everyone.
Cleveland's
Good evening, sir.
Good evening, Zahinia. All right. Must express my apologies for being absent. Well, I had to cut the class short yesterday. I had, I literally almost had a heart attack. Not a literal heart attack, but I had some very important assignments to be submitted yesterday, and apparently the deadline was not 11:59 p.m., but it was 11:59 a.m. So I was late. I got it in regardless, but I had to cut the class short. So for those of you who were in the class yesterday, for next week's class, you won't have to pay. I'll just transfer whatever it is that you had paid for this week to next week. All right.
Okay,
So,
sir.
all right. Lovely. All right. So for everyone else, you would have completed the worksheet, even though some aspects of it were missing. But there was plenty of questions on it that you could have done. What were your thoughts about the questions? Easy, hard, medium, clueless? Is there any particular question that was on the paper that you did not understand that you would like some clarity on tonight? Or are you just waiting for me to mark it and tell you what the results are? Nobody? Assuming that some person never get a chance to do it. All right.
Sir, there's no need to mark mine. I already look at the answers, the solution that you sent, and I see where I made some errors because I was rushed doing it. And
Right. I sent the solution for a reason because I was
yeah,
hoping that some of you guys would have actually tried to look at it and, after submitting, you would look at it and see where you went wrong.
yeah, man, I'm seeing it. And some of them they still have one or two challenge with in terms of,
Okay.
understand. Mm.
All right. Hi, Abigail. Good night. All right. So, is there any particular one that you'd like me to take a few minutes to kind of go through with you?
For me in particular,
Yeah, you or anybody else? Is there a
oh,
particular question on it that you saw that you had to think two or three times about it and you still never get it right before I move on to the next topic tonight? Or is the
oh,
answer sheet suffice?
the answer she's all right. For me, do me just try go over them and just start the ones that want me see me get right, and me just work it back all over.
All
It can
right.
be done, right.
Okay. Is there anyone else that would like me to go through any particular question that you saw on the paper that you need some clarity on?
Um, Not necessarily, but
Ah,
I, I'll the paper, the answer sheet will suffice. I'll go through and
all right.
sort it out.
All right. So,
However, I was rushing a bit.
yeah.
Really,
Yeah.
I wanted to sleep because I was doing it late and all of that. So I guess yeah, for future exams and I just need to get this SBA out of the way so that I can put some practice in because I haven't been doing any of that.
Right. I understand. All right. All right. So the answer sheet is in the Google Classroom. I try to work them out as best as I can, step by step. So just look at them, look at the solutions, and then see how best you can see how much you get right or wrong. All right. The reason why I did the answer sheet actually is because I know I'm not gonna have unless I have a live class where I'm working out the questions. I don't think I'm gonna have a time to do a particular video on it because I'm super busy with school and work. So I know I can't make another promise again and break it. So as it relates to making a personalized video based on that paper, no, I won't be able to do so. All right, too much. Me not have enough time on my hands. All right, nevertheless, still we have it's a new month, so we have to kind of put the past. It's now February. We are 3 months away from that penultimate day. We have much to do. We have a lot of work to do. So let's get started. All right. Since somebody else doesn't want to voice their opinion, I guess everybody else is okay, fairly. All right. So let's get started. Tonight is when? Tonight is Tuesday. My apologies for missing out last week Thursday because of internet issues again.
Sir,
Hopefully,
were you
yeah.
surprised? What did you say a while ago? Today
Last week Wednesday. Last week Wednesday.
Oh,
I made
okay.
a mistake. I keep mixing up. So today is Monday. My bad.
Right. Today's Monday, sir.
I did send you a supporting video though, so I'm hoping at least by Wednesday everybody should at least get through it so that we can just jump on it, or else not gonna force me to have to teach over the topic. But if not, if you
No,
want me to
sir.
teach,
I went on and I watched and made my notes and all of that. And it
okay.
was pretty good, I
Oh,
must say.
thank you, appreciate it.
Yes.
Thank you.
Yes.
All right, so people catch on because I'd love to come on Wednesday, and I would just love to come with a question, and then hopefully that the video is suffice enough to give you the understanding so we can just run through a couple of questions on Wednesday and then move on to the next topic. But for tonight, I'm assuming that we're on algebra, correct? Where did we last stop on algebra?
Yes, sir. We're on algebra. We stopped at quadratic.
Factorization.
Yes, sir.
Okay. Did we do any questions?
Yes, we did too.
We did 2. All right.
Yes.
Let's do a recap now. Okay. So, let's say you have turn off device side, right? Get some space. So let's say that you're asked to factorize. Say that you're asked to factorize 3x squared let me just zoom up here for a second. Hold on. The external meeting participant cannot access the whiteboard after the meeting. Disable the account. That keeps coming up. All right, so let's say that you're asked to factorize 3x squared plus let's do a couple of examples. So 3x squared plus, let me see here, 7x. Let's keep it simple. Plus 4. All right, let's keep it simple. So you're asked to factorize 3x squared plus 7x plus 4. Now remember, step 1 is to find the product A and C. So you're going to multiply 3 times 4, and you would have gotten 12. And then obviously now we're going to say list the factors of 12. So we know that 1 and 12 can give us 12. 1 times 12 will give us 12, pardon me. 6 times 2 will give us 12. And 3 times 4 will give us 12. Now the objective of listing out those factors is to choose one of the pairs that will either add or subtract to give you the middle term here. So the objective is trying to get back the 7. So we need to choose a pair that if we add it, it may give us the 7. Or if we try add it and it don't work, we try subtract it and it gives us the middle term. And if you look at it carefully, it's quite evident that the answer is going to be 3 and 4. Because if I make the 3 plus and I make the 4 plus, I'm going to end up with a positive 7. All right? So now that my choice has been made, I'm going to go ahead then and I'm going to bring down this term. And then I'm going to replace the 7x with the 2 terms I've selected. So I'm going to put plus 3x here. I'm going to put plus 4x here. And I'm going to put down plus 4. So this 3x here and this 4x here is coming from the terms I selected right here and here. And when you add them together, you basically get back 7. So it's the same expression.
Here, I'm not wasting my time on.
A second, guys. Hold on. All right. So sorry about that. So now that we have those 2 terms in the middle, we're going to go ahead and we're going to place them into 2 brackets like this. Like so and like so. All right. Now, if you look at the first pair of brackets, you'll realize that there's a common number repeating itself. That's the 3 and also the x as well. So if I pull out a 3 and I pull out one of the x's, I'm going to open a bracket. Now, you have 3x squared. 3x squared means 3 times x, right? So the 3 cancels the 3, and the x that I pull out cancels one of the x from the x squared. And I'm left with only one x here. And 3x into 3x goes one time. Plus, over the other side, you realize that there's a 4 that's repeating itself. So I'm going to pull out a 4. And the 4 cancels the 4, leaving me with x. And 4 into 4 goes one time. Now, if you'll notice here that there's a bracket that's repeating itself. So this bracket then implies that it's going to be 3x, well, pardon me. I'm going to take out the one that's common first of all. Pardon me. So the common factor is x plus 1. And the remaining factor is 3x plus 4. And that's factorized. Okay? So that is how you will process that expression. We're going to do a couple more, right? I'm going to try to take this up to about 7:35 to see if we can get a couple of questions in. And then we have to move on to a very important part of algebra, which is solving equations. All right? Any questions on that?
Sir?
Yes, go ahead.
Sir, if we're doing this equation, right? And we do the third part, before we rearrange the final answer, would it still be correct or?
If you do the third part,
Yes, sir.
right, this line here, so hold on, wait. If we do
The blue
this
line.
here, so
Yes. Would it still be incorrect if we don't do the bottom, the last step that you showed?
this last step, if you don't put this last step, it's not incorrect, it's just incomplete.
Oh, okay. Thank you.
Yeah. All right. Let's do a couple more examples. Some person will catch on eventually. Let me just zoom out here and just slide over this here, and then zoom back up again. Hold on, here we go. All right. So let's try another one. Let's make it a little bit more challenging. Okay. All right. So let's erase this. All right, here we go. All right, so let's say that you're asked to factorize Factorize, factorize. Oh, okay. Let's try this one. Let's do 4x squared. And we're going to do, let's say, let me think. All right, let me think. Let me do 4x squared. All right, yeah. So 4x squared plus x minus 5. All right, let's do this one. We need to factorize this expression. All right. So step 1 is to go ahead and you're going to multiply a times c. 4 times 5 or 4 times negative 5. In this case, it's 4 times negative 5. That's going to give us negative 20. All right. All right. Now, what we're going to do is that we're going to break up the 20 into factors. So we know that 1 times 20 will give us 20. 2 times 10 will give us 20. And 4 times 5 will give us 20. Now we need to make a decision. We need to choose one of those pairs. One of those pairs will multiply to give you back the number in the middle here. Sir, number in the middle? I don't see a number. There is a number there. It's just that you don't see it, but it's 1. So you need to choose the pair that if you subtract or add, right? So sometimes if you subtract it, it will work. Sometimes if you add it, it will work, right? It will give you at the middle. Now, obviously, there's nothing you can do with 1 and 20 that will produce 1. If you add it together, you get 21. If you subtract, you get 19. If you add 2 to 10, you're going to get 12. And if you take 2 from 10, you're going to get 8. The only one there that seems to me be able to work is 4 and 5. Because if you take away 4 from 5, you'll get 1. So I'm going to make this a negative 4, and I'm going to make this a positive 5. All right? So both of those will add or subtract to give me a 1. And then, of course, if I multiply it, it will give me back negative 20. All right, so we're going to go ahead and say 4x squared. Pardon me, guys.
Utter trash can easily be sent back.
So that's 4x squared. And then now remember that this term in the middle, it's gonna disappear. And we're gonna take these two terms and we're gonna put them right in the center here. So we're gonna have minus 4x plus 5x minus 5. Now that we have that situation, we're gonna go ahead then and we're gonna put them into groups of 2. So we're gonna put a group here. All right, so we're gonna have a group here, here, and right here as well. All right. Now, common factor. In the first bracket, you see that there's a 4 repeating itself. So we're going to pull out the 4. And you also see that x is also repeating itself. So I'm going to pull out the x. Now, if I pull out the 4, it's on the outside, and I pull out one of those x's. Remember, there's 2 x's here now. And I have one on the outside, so one has to be left on the inside. And then obviously 4x will divide into itself one time. So 4x into 4x goes one time. Next bracket, you see that the 5 is repeating itself. So I'm going to pull out a 5 here. Open the bracket. If I pull out the 5, only the x is left. And 5 into 5 goes one time. So therefore, you'll realize then that the common factor here is x minus 1. And the remaining factor is 4x plus 5. All right? And that's how you factorize this type of expression. Okay? So I'm going to give you 3 minutes or so until about 7:30 to try one for yourself. And then we have to move on, right? Because we have our Sunday class and Saturday classes that we do these things on. So I just have enough time to kind of go through these examples and then, we have to practice them outside. But we have a very important topic to cover tonight. So I'm going to give you one to try and let me see if you can handle it, okay? So here we go. You're going to try this one for me, please. Uh-oh, big zoom. All right, so I'm going to go ahead and try this one for me, please. Go ahead and factorize the following expression. We have, okay, this one is a nice one. Let me see if you can figure this one out. Factorize. So factorize 3x squared. All right. I'm going to give, okay, so 3x squared minus 13x. Uh-oh, where did my board go? Guys, are you guys still seeing my board?
Yes, sir.
Yes, sir.
Hold on, wait. I think I lost my
Yes,
board.
sir.
Did I lose my board? Wait, give me a sec. Are you guys still seeing the board itself?
Yes, sir.
Yes, sir.
Oh my lord. Where did my board go? Last 27. I'm not seeing my board. Where is my board? Oh lord. Alright, I gotta change my board, guys, because I can't find it back. Alright, sorry. So here we go. Natalia, why are you writing on my board?
Sorry, sir. My hand just touched the screen.
They're
I'm just
probably
messing around.
think someone was trying to let you recover it.
Okay. Alright. So try this one for me, guys. 3x squared minus 13x plus 10. Go ahead and factorize this expression for me. I'm giving you until about 7:32. All right, don't take too long now.
I'm finished.
Good job. Good job. Hold on. Oh, 7:32 as the time fly fast. Oh my. All right, let's see. Let's see. Are you near done? Or this one's supposed to trick you, you know? It's supposed to trick you. Let us see if it tricks you. Let us see. All right. So 3 times 10. All right. Nicolita says it's x minus 2 and 3x minus 5. All right, let's see. So 3 times 10, that's going to give us 30. If I break this up, I'm going to get 1 and 30. I'm going to get 2 and 15. I'm going to get 10 and 3. And I'm going to get 6 and 5. Now, here's a challenge now. I gave you this one specifically because I knew it was going to happen, right? This can't work and this can't work. Both of them can give you back at negative 13. Both of them, if you check it. If I make, all right, Dominic, I see the answer, 3x minus 10x minus 1. That one, they look shaky, don't you, Dominic? That one, they look shaky. All right, let us see now. All right, so for these two, both of them can give you back negative 13 because I can say plus 2 and I can say minus 15. That will give me back negative 13. And I can say minus 10, comma, minus 3. Both of them give you back minus 13. However, only one of them will multiply to give you back 30. So if you chose 2 and 15, you are incorrect. The chosen factor is 10 and 3. Dominic, you look like you're right, you know? You look like you're right. So, sorry for the persons who chose 2 and 15. The answer, the chosen pair should be 10 and negative 10, negative 3, because negative 10 minus 3 gives negative 13, and negative 10 times negative 3 gives back positive 30. So the chosen pair should be negative 10 and 3. All right. So 3x squared minus 10x minus 3. Oops, you know what? Let me put this 10x over here. So it's better that way. It doesn't matter really, no, but I prefer putting it this way. Minus 10x plus 10. Dominic, you look like you're right. I apologize, sir. A common factor here is 3x, bracket x minus 1. And then you have minus 10 over here, open bracket, x minus 1. So my best bet, Nicolita, is that you chose the incorrect pair. Am I guessing right?
Sir, it can still work.
No. Yeah, work.
But sir, so what, they use a negative 6 and a negative 5. It's negative 13.
No, negative 11 that.
Oh.
Oh. I know, see, I was say, oh. All right. So 3x minus 10, Dominic, congrats, you got it right. And x minus 1. Perfect. That is it. All right, so that is how you factorize that type of expression.
Excuse me, sir.
Yes, go ahead. Question.
Question. Does it matter whether the 10 come before the 3 or the 3 come before the 10?
No, it doesn't matter. If you want, do you want me to do it your way?
I'm just asking because I used the 3 before the 10.
No problem. Let me use the 3 before the 10. As in, that's what I did. I put the 3 before the 10. See it here, so.
Before you did put the 10.
Okay, so let me do it with the 10 first.
Yes.
No matter. Let me just go ahead and do that one. All right. So, hold on. Negative 13. Where's that 10 coming from? That's 3 minus 10. Wait, how this looks so? Why is this looking? Oh, yeah, man, it's right. All right, good. So, common factor then. Over here, x is common. And then 3x is going to be left in the bracket. And I remove the x from the 10. I'm going to end up with 10. Over here, it's tricky because the only number that can go into 3 and into 10 is 1. And you're going to have x minus 10. You're going to have 3x minus 10. So that's why I cannot put the 3 on this side because it's going to be very difficult for a lot of person to realize that 1 is the common factor right there and there. So it's still going to be x minus 10 and it's going to be 3x minus 10. Doesn't matter which side you're on. As long as it's the same thing. So same answer. All right, so that pretty much would end the topic of factorization. We just need to just do some practicing on it, right? In fact, this weekend coming, I wish you guys could come face to face. But this weekend coming, I'll be doing a whole entire algebra worksheet, right? I'll be going through all the algebra that we have or we should be doing. So we're doing a full coverage of algebra worksheet. Last week, we did a whole, well, apart from the fact that I didn't get a chance to do it on Sunday, we actually went through a whole coordinate geometry worksheet. But all right, well, they are going to do it same way. All right, so tonight, guys, here's what the important thing for tonight is we're going to go through.
Sir, what is the Saturday class again? What time was Saturday? 1
p.m.
o'clock?
1 p.m. Yeah.
All right, I'm gonna try and come out.
Okay. All right, so that ends this topic. We are going to move on to a very, very crucial topic. And this topic is going to be a part of almost everything that you will do in the future. Okay? So what's the name of this topic tonight? We are going to be looking at linear equations. So we are moving away from simplifying expressions to moving to linear equations. Linear equations. Very important topic. I have an hour. I'm going to try to do the best that I can do within this hour. All right? All right. So, linear equations. What is an equation? Sir, weren't we just doing equations? No, we were not. We were actually simplifying. All this time, all the algebra that we've been doing simplification. Check the instruction. The only instruction that's different from simplifying was factorizing. Every expression that I've taught you thus far is a simplification process. But now we're going to be moving into something known as solving. So we're going to be looking at how to solve an equation. Oops. Oh, that's fine. That's fine. It happens. It happens to me when I'm in my online class at NCU too. How to solve an equation. All right. So how do we solve an equation? Well, there are some rules that you're going to need to be aware of when it comes to solving equations. And I'm going to list them for you here. So, rule number 1. There's something in an equation known as a subject. So the question is, what is a subject? So the subject is mathematics or English or no, guys, no. The subject in an equation, the subject is the variable that you're trying to find the value of. So the subject is the variable that you are trying to find the value of. Sorry for my bad handwriting, guys. So the subject is the variable that you're trying to find the value of. For example, if I say x plus 5 equals 10, then my subject is the x. My subject is the x. That's what I'm trying to find the value of. I'm trying to find out what number must I add to 5 to get 10. If I write an equation, let's say 3x, all right, let's not use x. Let's say I have a question that says 3a equals 12. My subject is the a. I'm trying to find out what number should I multiply by 3 to get 12. So when I give you an equation and it has a letter or it has more than one letter in it, the variables are called the subject. And that's what you're trying to solve for. Now, you're going to encounter 2 or 3 different types of equations, right? You're going to meet up on something known as an equation, where you have the equal sign. And then you have another one that we call, give me a sec here. You have another one that we call an inequality. So it's going to look something more like this. It's going to look like x plus 3 is less than 5, something like that. So if you notice the difference here is you have an equation and you have, hold on, let me use a different color ink so we can see the difference. So you have something called an equation, which is the one with the equal sign. And you have the one with the greater than sign or the less than sign that we call an inequation or an inequality. So Mr. Peart, what is the difference between the two? The difference between the two is that with an equation, right? Let me just give you the difference, right? So with an equation, when you solve an equation, you get what is known as an exact value. That means if I say to you that x is equal to 4, x cannot be 2, x cannot be 3, x cannot be 3.9, x cannot be 4.1, x can only be 4 and 4 alone. However, this is known as an exact value that makes the equation true. Any other value other than 4, it will cause the equation to be incorrect. Now, if I wrote here x is greater than 1, does it mean that x is 1? It actually doesn't mean that x is 1. It actually means that x can be 2, 3, 4, 5, and obviously, I'll sit down here with you and count all the way to a million or infinity. So I'm just going to say, and so on to infinity. So what this does, ladies and gentlemen, is that this inequality gives you what is called a range of possible solutions. So it gives you a range of possible solutions. So there's no one value that will make the equation or the inequality true. You have infinitely many solutions that will make the equation true. But that's not the point of this topic, right? Because what I'm telling you right now is some advanced stuff, right? There's some important things you need to know to be an effective student when it comes to solving an equation. Identifying them is one, but solving them is another thing. So here are some rules that I needed to be aware of, right? I'm going to pull up a notepad. Hopefully I can write on it. I don't know. Can I write in it? I guess I saw. I don't know. Can I? Let me see if I can write in it. Is the font size? I don't know how to use this thing, you know. Oh no, it's too big. Font size is small, so I don't know. Let me just delete it. Oh no, don't clear that. All right. So here are some rules. I'm gonna just write it in my hand here, guys. All right, so here are some rules. Rule number 1. You must learn this skill known as transposition. Sir, what is transposition? It's when you carry something across the equal sign, right? So let's say I have something like x plus 4 equal 5. If I carry this 4 on the other side, that's called transposition. Or if I have something like 5 equals y minus 2, if I carry the 2 on that side, it's called transposition. So transposition is a tool or is a skill that you need when you're moving an obstacle that's attached to your subject, right? So my subject is x in this case, and I need to move the 4 away from it. So I'm going to move it on the other side. That technique is called a transposition. Or in example number 2, I have the -2 on the right side of the equation, and I want to move it on the other side. That's called transposition. Now, a very key thing to remember about transposition is that if you transpose a term, doesn't matter if it's a subject or a number, if you transpose anything at all, the signs will change. The signs will change. So if I move this +4 over here, when the +4 goes over, it's going to become a -4. And if I move this -2 over here, I'm going to end up with a +2. So if you move plus to the right or to the left, it's going to become negative. And if you move negative to the left or to the right, it's going to become a positive. So just remember, when it comes to the transposition, whatever you do, whatever you move, make certain that you change the sign. All right? Make sure you change the sign. Next thing that you need to know about transposition is, let me just grab this black ink here. All right. Now, the next thing you need to know about transposition is your subject, which is the variable that you're trying to solve for, your subject should always be positive. Try to ensure that at all times, there are going to be some situations where you can't avoid it, but as long as you have the ability to keep the subject positive, please do. Your subject should always be positive. That means there should be nothing under it. There should be nothing behind it. There should be nothing in front of it. There should be nothing on top of it. And it should not be raised to a power. So I should not see something like 2x, or I should not see something like x over 3. I shouldn't see something like, let's say, x squared. I shouldn't see something like 2 over x. There should be nothing beside it, below it, raised to a power, or under it, or over it, sorry, pardon me. So your subject should always be isolated, and it should always be positive at all times. So that's what we want to keep in mind. Those are the 2 main rules when it comes to equations. Now let's put it all together, right? Because it sounds like a whole bunch of information, a whole bunch of stuff that you probably feel like you don't understand. Let's put it all together then. Let us put it all together. All right, so I'm going to put 4 equations on the board, very common equations that these equations are going to be situations that you're going to see very, very often, right? And the ability to solve these 4 basic principles of equations will put you in a very good position to solve any equations, in fact. All right, so I'm going to write them on the screen here. First one is going to be something like, I'm going to use different variables as well. I don't want you guys to get stuck into the idea that an equation is always in respect to x. So here we have, oh, let me zoom up. This is 2, okay. All right, so here we have x plus 4 equals 7. I have to zoom out a little bit, guys. Come on, more space. All right, so x plus 4 equals 7. That's 1. We have y minus 2 equals 3. we have a over 4. Let me just try to get this better here. I have a over 4. I'm not writing well. So I have a over 4 equals 2. And I have, now I want to put this one last. How do I duplicate this? Okay. All right, good. So you know what? Let me just erase this. I have 3a equals 2, and I have x, y, a, and b. I have b over 5 equals 7. All right? So I'm going to put them in now. Like that, like so. So you see what I want. 4 different problems. All right, so these 4 problems are fundamental principles of solving an equation. One of them involves an addition sign. The second one involves a subtraction sign. The other one involves a division. And the last one involves, the third one involves a multiplication. And the last one involves a division. I'm going to show you how to isolate. Let me use that word here. Isolate. So I'm going to isolate the variable. All right. So here we go now. I want to find the value of x. Mathematically, what this is saying is that there is a number that when I add 4 to it, I'm going to get 7. A normal person will know that the answer is 3. But it's very obvious to see that it's 3 because the equation is in terms of a positive number and it doesn't have a lot of complications in it. So we want a technique that we can use that's consistent with every and any equation, regardless of the structure. So here's what we do. If I want to find x, my objective here is to try to get the 4 or to remove the 4 from beside the x. So I'm going to go ahead, I'm going to bring this 4 on the other side. And so what I'm going to get then is going to be x is equal to 7. The positive 4 was transposed. So it's going to become minus 4. So x works out to be 3. Very straightforward. Nothing too challenging there. The process is similar with example number 2, where I want to find the value of y. So I'm going to go ahead, I'm going to put that negative 2 on the other side, put that arrow here. And so what's going to happen then is that I'm going to go ahead and I'm going to say y. Whoops. What is that? Where did this come from? Come disappeared. We're going to have y is equal to 3. Notice I bring the minus 2 over. It's going to become positive 2. Positive 2, yeah. So then this works out to be y is equal to 5. Very straightforward. So what am I saying then? I'm saying that if I have a number that is attached to a particular variable by addition or by subtraction, the rule is to carry it over to the other side. And when you move it on the other side, whether you move it to the left or to the right, the aim is to move it to the other side, left or right, and make sure so you change the sign. So plus will be moved over, it becomes minus, and minus goes over and it becomes plus. Is it clear, everyone?
Yes, sir.
Okay. Now, number 3 and 4 is a little different. Number 3 and 4 is a little different. Because with number 3 and 4, for example, number 3, you can't carry this 3 over here. Right? You can't just lift up the 3 and carry it over here. Because the 3 and the A is kind of, we say that they're married. That's what we say in mathematics. They're married. So because they're married, in mathematics, marriage is indicated by a multiplication sign. So look at it carefully now, guys. You see, whenever you see one number that is attached to your variable and there's no sign between them, the understood sign is a multiplication. So how do we do this? We go ahead and we say 3a divided by 3 is equal to 2 divided by 3. Huh? So we just do a while ago. All right, let me just go again. Basically, what I've done is that I'm trying to get this a to be alone. And I need to get rid of this 3 here. So I need to get rid of this 3. And the only way to get rid of this 3 is to divide by 3. I'm going to take this 3a here, right? That's what I had first. I'm going to divide it by what I do not want. So I don't want this 3 to be there. But because it's an equation, I have to keep it balanced. So I also have to divide the other side by 3 as well. So I'm going to go ahead and say 2 divided by 3. Watch what's going to happen. This 3 is going to cancel this 3. I'm going to end up with a is equal to 2/3. Don't turn it to a decimal. 2/3 is fine. Remember the objective, you know? The objective of solving an equation is to ensure that the subject is isolated. And the word isolated means all by itself. So my objective is to always, my aim is always, and my focus is always to get that subject to be by itself. If something is beside it by plus, I move it over the other side. If something is attached to it by minus, I move it on the other side. If something is married to it, I'm going to divide it by what I do not want. And like in example number 4 here, there is something underneath my subject. That's the 5. Here's my subject, the b, and there is something underneath it. So because under the b is known as division, the opposite of division is to multiply. Pay attention to what I'm going to do here. I'm going to go again. I'm going to go ahead and I'm going to say 5 multiplied by b over 5. And that's equal to 7 times 5. So I multiply this term that was right here by 5. Sir, why you multiply by 5? Because what's hindering me from getting the b by itself is the 5. So I'm always going to multiply or divide by what I do not want. And because it's an equation, I have to balance it by doing the same thing on the other side. Look what happened now. This 5 will cancel that 5. And I'm left with b. So b is equal to 35. Those are my solutions right here. Any questions on those 4?
No, sir.
Any questions?
No, sir.
I heard you, Zayenia. Everybody good? Everybody
Sir,
good? Yes, question.
being that you know that you will have to change the signs, if you just bring it over and change the sign, would that be incorrect, or you
No,
have
man.
to
No, for
show
you
that?
can cut. No, man, you can cut steps, man.
Okay.
You can just go right there and move from here, go all the way here. So if x plus 4 is equal to 7, in your head, you can just say x is equal to 3.
Oh.
Yeah, man. All right. Assuming that silence is golden.
Sir,
Yes, question.
sir, question. For the last 2 equations that we worked, so it simply means that whenever the equation requires you to multiply to separate the variable from the number you divide.
That is correct.
Okay, and then when it requires division, you multiply.
Correct.
Okay, thank you.
So we're using the opposite operation to get rid of to isolate our variable.
Thank you, sir.
Okay. All right. So those are the 4 fundamental principles. Now I'm going to introduce you to something, right? All right. So we don't call them all right. So they are called equations, but we also call them a formula as well. All right. Let me show you something. All right. This comes up a lot. So here is this example. I'm gonna zoom out here. Get this one up here. All right. Here we go. All right. Good. So look at these ones. I'm going to write some other ones that are very similar to what I just did. Look at this one here. Zoom out. Oh. All right. So you look at these ones now. Oh, so small. A minus V equals T. X plus R equals Y. Okay, where's Mr. Pete going with this? 3T equals S. What is Mr. Peart doing? And we have V over 4. Or no, let's just use a letter. So we have V over W equals X. Here's the instructions now. For this one on the left here, I'm going to write a simple instruction here. It's going to say 4A. For A. All right, so that's what the instruction says, 4A. In fact, you know what? Let me just don't write 4A. Let's just write the actual thing. All of these, same instructions. Solve. Pardon me, guys. I'm not used to this platform. I'm getting used to it. So solve for A. This one says solve for R. This one is solve for T. And the other one over here is saying that we should solve for V. And they're very similar. Pardon me. All right. So it's very similar to what we did earlier. All right. So in this case now, we actually shouldn't use the word solve because you can't really solve these, right? I won't be able to tell you an exact value for the letters. So why I use the word solve is that I'm trying to create a relationship between what you just did and what you're doing now. So we won't see the word solve when you see these examples. You'll see the words express as, or write in terms of, or for this letter, or make that letter the subject of. We don't use the word solve because the word solve means that there's a solution to the problem. And for these, we won't be able to tell what the solution is. But the principle remains the same. Look at this. So here, this question says that we should solve for A. It means that A is okay, Tishana. Solve for A. A is the subject. That means I'm trying to get this letter to be all by itself. How do I get that letter to be all by itself? It's very evident that there's a negative V that's beside it. So to get A by itself, or to solve for A, I'm going to bring the minus V over here. And so what I'm going to end up with then is A is equal to T plus V. Funny enough, guys, that's the answer. A is equal to T plus V. So how that will be the answer? Remember, I'm just telling you now, you cannot solve it. I don't know what T is, and I don't know what V is. If I knew what T and V was, then I could tell you what A is. But for now, I can only tell you what expression will eventually give me the value of A if I knew what the value of those letters are. So this is where we have what is called transposition. I don't know what them call it in high school. In high school, them call it transposition of the formula. So them call it, or rearranging the subject of the formula. Not some fancy names that they use in high school. All right. So in this case here, all I did, just like in the first example, my objective is to get the A by itself. So I'm going to move whatever is beside my subject. Let's practice. For this second one, I want to solve for R. Who do you think I need to move? I want R to be alone. So who do you think needs to go to the other side?
X.
X. X. So I'm going to move X over. Question, is X positive or negative?
Negative.
Negative.
Oh, sorry, you're talking about when it's moved, or what was it? Is it positive now?
When it's moved, it's
okay, when it's
positive
moved,
now.
Right. Thank you. So when it's moved, it's going to be R, pardon me, it's going to be R is equal to, what do you think? Y take away X. That's it. That's your answer. All right? When I have nothing more to do. The objective in the people, remember that the objective of an equation or a formula is to get the variable to be by itself. When a busy work one, we don't care about what's going on the right. It's the moment we mathematically get the subject to be all by itself, whatever goes on the right can go on. My objective is to make sure that the A is by itself and the R is by itself. Now, in this example, I want, say here, let me just grab this. T is what I want. It says solve for T. But there's something beside T. What's the relationship between the thing that's attached to T? What's the relationship between them? What connects them?
They're married.
They're married. And marriage in mathematics means what?
Multiplication.
So what's the opposite of multiply?
Divide.
We're going to go ahead and we're going to say 3T divided by 3. And that's equal to, that is correct, S divided by 3. So we cancel these two. T is equal to S over 3. That's it. S over 3. All right? And that's not 5 over 3. Remember, right to go. This is S, guys. But I want you guys to write our foolishness. This is S over 3. All right, over here. I want to solve for V. That's the V. But something there underneath the V. When you're under the subject, what does that imply? What sign in mathematics does that imply?
Divide.
What's the opposite of divide?
Multiplication. Multiply.
I'm going to say W. I'm going to multiply by what I do not want. And remember, you have to do it on both sides, So that's going to be W multiplied by V over W. And that's equal to W, pay attention, multiplied by X. Whoops. I'm multiplying it. I'm going to use a dot, okay, guys? Because, my multiplication sign and that X look the same way. So I'm going to use a dot. A dot in mathematics means multiply. So I'm going to multiply both sides by W. Notice that this W will cancel this W. So I'm now left with V, which is ultimate objective is to get V by itself. And W times X becomes WX. All right? So all of those 8 fundamental examples, right? The first 4 was as it relates to an equation. And the last 4 examples were as it relates to an expression. Well, it's still an equation because it involves an equal sign. But it's more like you're not able to solve it. You're just able to rearrange it. So I'm going to cross out the word solve now, and I'm going to put rearrange. Rearrange for A. Rearrange. 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 Remember, guys, I'm not going to use certain words for you, so get used to it. Rearrange and rearrange. Okay? So rearrange for A, rearrange for R, rearrange for T, rearrange for V. I'm going to give you some other words that they'll use as I go along through this example. All right? Now, here is where butter meet bread. And here's where knife run through butter. Is when we start put all of them together. So look at this now. Butter meet bread now, ladies and gentlemen. All right, so now, here's an example. An example. Solve the equation for x. Let me keep it x, right? Solve the equation for x. That's the instruction. 3x minus 2 over 3. 3x minus 2 over 3 is equal to 10. Oh, Lord have mercy. 3x minus 2 over 3 equal 10. Now, all of a sudden, this does look like nothing that Mr. Pierre just teach me. It has aspects of what Mr. Pierre taught me, but I don't know what to do first. Now, my question to you is, here's the question now, and think about it carefully. It's a trick question. Name, you know what? Let's not use this number. No, I use it twice. Hold on. Get rid of this here. And just put 5 there. Want a distinctive difference between them. All right. So question to you now, class. What are the terms that's preventing me from having x to be all by itself? That's the first question I want to ask. Name them. It's 3 of them. Name them. Anybody? There are 3 things preventing me from getting x to be all by itself. What are they?
X
Galia.
is
Correct, Galia. Go ahead, Nicolita.
X is multiplied by 3, and you have 2/5 is take away 8 minus
2/5, right? So the 5th is under the 2.
sign. It's
Right,
under,
correct.
so
That is
you'll
correct.
have
That is correct. That is absolutely correct. So we have the 3 that's married to the x, and we have the 2/5 that's been subtracted from the x. Now, I'm going to look at 2/5 as 2 different terms. I'm going to look at the 2/5 as the 2 and as the 5. So for me, the 5 is underneath the 2. We need to get rid of that. I need to also get rid of the 2, and I need to get rid of the 3. The question is, who goes first? Who do you get rid of first? Who's the first? If I want to get x by itself, who do you think is the first thing you need to get rid of?
the 3.
Too close. Too close, Galia. That's the last thing you have to get rid of first. Who goes first?
The
2/5.
The 2/5. Look at the 2/5 as 2 different numbers. What's under the bottom?
5.
Correct. You're going to get rid of the 5 first. Sir, how do you get rid of the 5? The same way you get rid of the term up here. Let's go back up to this example. Remember how we get rid of the 5 that was up here? What did we do when we had the 5 under the bottom? We multiplied both sides by 5, not true? Is that what we
Yes, sir.
did? Right. So if you have something under the bottom of an equation, you're going to multiply everything by that number. Let's go back down here then. So watch carefully now. I'm going to use some blacking to show you how I go on. Watch carefully. Watch how I go on. I'm going to take the 5. Mr. Pierre. So I'm going to take the 5. And I'm going to multiply it by the 3x. Watch out now. I'm going to take the 5 again. And we're going to multiply it by the 2/5. And we're going to take the 5 again and multiply it by the 10. Sir, so why you multiply everything? Why you multiply by 5 so much time? I multiply by 5 so much time because remember it's an equation. If I choose to multiply one thing by 5, I have to multiply every single thing by 5. Sir, why? Remember, if you walk into a room and you see 3 hungry people and you give one person food, don't you think it's very unfair to leave the other 2 persons hungry? It's natural. So if I multiply by 5 for one term, everybody has to be multiplied by 5 so that everything remains balanced. If I go in there and I have 3 sweets and there's 3 persons in the room and I give one person 2 sweets and the other person 1, and the
Sir,
third
the
person
sound is, your voice is going down.
voice is going. Are you still here? Are you hearing me now?
It's clear, yes, it's better.
Okay, right. So if you go into a room and there's 3 persons in the room and you have 3 sweets, the natural thing to do is to give each person 1. But you decide to give 2 persons a sweet. You decide to give 1 person 2 sweet and the other person 1 sweet, and then the third person has none. That's unfair. It's not balanced. So it's the same thing here. Because I'm trying to get rid of this 5 that's underneath the 2, I'm going to multiply by 5. Not true? But remember, so what about these persons here? They're going to be affected as well. So you have to multiply everybody by 5. Or by whatever is at the bottom. So now, watch this now. 5 times 3x, 15x. Watch this now. You see that 5 here? Cancel that 5 here. So you end up with what? Minus 2. And that's equal to 5 times 10 is 50. Now look at the equation that you have now. The equation that you have now is what? To bring the 2 over on the other side. So we end up with 15x is equal to, when I move negative 2, what am I going to get? Positive 2. So I'm going to end up with 15x equals 52. And now the 15 is married to the x. So all the rules that you've just learned is being applied in one question. So 15x equals 52. X will be equal to 52 divided by 15. That is correct, Dominic. 52 divided by 15. Sir, do I express that to a mixed fraction? Not necessary. Do I put it to a decimal? Not necessary. If you get 52 over 2, if you can't go down no further, if 3 cannot go into 52, leave it be. If 5 cannot go into 52, leave it be. So your answer is just x is equal to 52 over 5. All right? That's an example. No, I know what you guys are thinking. Some of you, I know what you guys are thinking. Trust me, a long time I teach maths, so I know what someone I think. Some of you guys are saying, sir, I don't want to work it that way because that the way they look too long and it look hard and whatever. Hold on, I think I learned a trick the other day. Now. Hopefully get one straight line on this thing here, so. Oh, wicked, Mr. Peart. All right. All right, so ready now. So I know what you guys are saying, right? You're saying to yourself, then, sir, because person look at the math differently. Some persons are saying to themselves, then, sir, I see a 3 that's attached to the x and I see a whole entire 2/5. Let's write it down. 3x minus 2/5 equals 10. Sir, could I not carry the 2/5 over here? Of course you can. You can go ahead and say 3x is equal to 10 plus 2/5. And then if you want, you can go ahead and find the LCM. No problem. If you like it that way, no problem. It's perfectly accepted. What's the LCM? 5. The problem is when students get nervous, then we go make mistake and say 10 plus 2 or 12 over 5. Oh God, and get the question wrong. 1 into 5, 5. And 5 into 5, 1. So you're going to end up with what now? 50 plus 2 over 5. So you're going to end up with what? 3x equal 52 over 5. You still have to go multiply by 5 now. So it's technically you kind of just make the problem harder than what it seems to be. That's just my opinion though. If you can find your way to wrap your mind around this method, no problem. Because everything that you're trying to avoid, you're eventually going to have to do it anyways. So my best bet is, and here's the rule, guys. When you get an equation like this, if there's a term at the bottom, make sure so you get rid of the term that's at the bottom first. So you get rid of the division, then you get rid of the subtraction, then you get rid of the multiplication. All right? That's how you do it. You get rid of the bottom, get rid of the addition or the subtraction, then you get rid of the multiplication. So at all times, this is what you do. It's never going to change. At all times, whatever is at the bottom goes first, then the subtraction or the addition goes second, then this one goes last. All right, let's do another example. See if we can catch it. Look at this now. Solve the equation, same instruction. Same instruction. Oh, what is going on here? All right, here we go. All right, good. So solve this equation now. We are going to solve it. 5 minus 3x. Oh, let's use 5. So 5 minus 7x over 2 is equal to 10. And you're asked to solve that. What are the 3 things that are preventing you from getting x by itself? What are they?
5, 7, and 2.
Say it again. 5, 7, and 2?
Yes, sir.
5, 7, and 2. All right, 5, 7, and 2. I'll work with that. All right. Who goes first? Who do we need to get rid of first? Who do we need to deal with first?
The 2.
Correct. Deal with the 2. So what we're going to do with the 2? We're going to say 2 multiplied by 5. We're going to say 2 multiplied by 7x over 2. And we're going to say 2 multiplied by 10. We use the 2 and multiply everybody. Everybody gets affected by the 2. Already know, we're going to cancel out. Who is that? All right. So we're going to go ahead and cancel out now. Watch this now. 2 times 5 is 10. And this 2 cancels this 2. So you end up with, so 10 minus 7x. And that's equal to 20. So 10, that's the 2 times 5 is 10. Minus comes back down right here. So the 7x come back down equals 20. Now, I can go ahead now and I can, who am I going to, am I going to carry over the 10 or am I going to carry over the 7x? Which one? What do you want to do? It doesn't matter. What do you want to do? Do you want to bring over this? Do you want to bring over the 10 or do you want to bring over the 7? The negative 7x?
Negative 7x.
All right, we're going to bring this over here so it can become positive and bring this back over here. No problem. So we're going to have 10, right? Because we never touched the 10 there. We move the positive 20, it becomes negative 20. And we move the negative 7x and it becomes positive 7x. What's 10 minus 20? Negative 10. All right, what's attached to the x now?
7.
Correct? We're going to go ahead and divide by 7. And so we're going to end up with an answer that says x is equal to negative 10 sevenths. And that's it. That's your answer. Negative 10 over 7. Right? That is how you work out that equation. And there's plenty of them, like I said, there's plenty of them. Give you another one. We have some time. We have a couple of minutes. And I have an actual full tutorial on this, you know. But we have to go find that video they know. The video in my children and videos that I've posted. Oh Lord. The old videos, it probably doesn't have the quality or the audio quality that I would like. So I'm not going to recommend that video there. But it's alright. It's an okay video. Alright, so let's try this one. You guys tell me, I want some assistance with this one. Alright? I want some assistance. Tell me, what do you think I would need to do to solve this equation here? Let's blow it up and make it big. Right. So I need some help. Help, 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 help. Solve. Oops. All right, here we go. All right. Solve the equation. All right, ready? All right. 3x minus 2 over 7 is equal to 5 over 2. I need some help. Typical CXC question. How would you solve this? What would you do? If somebody can single-handedly take on this question and tell me and get it right, I give you 5% on your next month's test. Free. Who wants to take the challenge? Any takers?
Yes, sir.
All right, let's go ahead.
I'll try. So we're gonna get rid of the 7 first by multiplying 3x by 7 and the 2 by 7
So we'll go up to the 2.
and the 5 over 2 by 7.
We need to, so we have to find a way to get rid of
Then you
them both at the
multiply.
same time. It's not gonna be too much work.
Multiply.
I'm not saying that you
Multiply
can't
them
say
by
it.
2.
Yeah, we
Multiply
need to
by
get
2
rid of the
at the
both of
same
them.
time. So you use the 2 of them, sir. Multiply
but you
by
can't
7 and 2. You can do
So
it
what?
at
So what
once.
is so what is 7 times 2?
14.
So we can multiply by 14, mama. So we can say 14 times 3x minus 14 times 2 over 7 equals 14 times 5 over 2. You see how you can cancel them now? Tell me what cancels what now. Continue.
So 7 into 7, 1. 7 into 14, 2. 2 into 2, 1. 2 into 14, 7.
So fast to get rid of them one time? One time. Now tell me what I should write down now. Tell me what is left now on the screen. What's 14 times 3x?
Minus 2.
No, 14 times 3x. Right here. 42x. Correct? Yes or no?
14 times 3.
Yeah, 14 times 3x. What is 14 times 3x?
Yes, sir. 42.
42x. All right.
Yes.
What is minus 2 times 2?
Minus 4.
4.
Very good. And what is 7
Minus
times
3.
5?
35.
35.
Right. So look at the equation that we have now. We get rid of the 7 and we get rid of the 2 in one line. You could have multiplied by 7 first, and then multiply by 2. But that will just make the work harder. So you just find a number that can get rid of the 7 and the 2 at the same time.
Sir, bring over the
Yeah. Go bring over the 4 now. So what are you going to end up with?
Yes, sir.
42x equals 35 plus 4.
Plus 4.
Right. So 42x equals what?
39.
That's correct. And how do we get rid of the 42?
So multiply by 42.
Divide by 42. Because it's already multiplying the x. So divide by 42.
Yeah, divide.
And that is your answer. X is equal to 42. Okay? All right. So that's pretty much like a basic idea. Well, not a basic. You've gone through a lot of the advanced part of it. The only thing that I haven't showed you is the one that with inequality. May I take 5 minutes and show you an inequality question? Do you mind, or you want me to end it here?
Sure, sir.
Let me just show you a quick one. It won't take long. All right, so here we go, guys. Quick one. It won't take too long. What if you had something like 3x minus 7 is less than 4. This inequality sign doesn't it doesn't change anything. It's just that we're not using an equal sign, we're just using an inequality sign. So the rule doesn't change. So what would you do to get the x by itself? What would you do? There are two things preventing you from getting x by itself. It's the minus 7 and the 3. So what do we do with the minus 7?
Carry over this minus 7.
So you're gonna get what? 3x is less than 4 plus 7. That's all.
Yes.
So 3x is less than 11. How do I get rid of that 3?
Divide by the 3.
So 3x divided by 3 is equal to, sorry, not equal to, so that means I also get caught, you know. So 3x divided by 3 is less than 11 divided by 3. Cancel, cancel. X is less than 11 over 3. All right? So I'm going to send you in the group instead, not in the Google Classroom. I'm going to send you a page that has a couple of these types of questions. Them your own, right? It's not something for you to submit. It's just for you to practice on. I'm going to send you a worksheet that contains linear equations. And you can practice how to solve them and get your skills up. All right. In the meantime and in between time, guys, remember that I had already posted you a link to a video that we did. Sorry, for the class that we would have done last week. Miss Gentles will tell you that the video is, I guess, she said it's really good. So guys, check it out, right? See if you can make your notes from it so that when I come Wednesday, I can just come with a question and we can apply, right? How long is the video, Miss Gentles? Is it an hour? How long is it? 40 minutes, 45?
Yeah, it's less than an hour.
It's less than an hour, which is basically like a class time.
Yes.
So if you can watch it tomorrow, it would help out a lot. It would help us out a lot. We wouldn't have to come to class to go through the whole aspects of graphing and right. I could just come to class and do like a couple of questions. All right. So please check it out for me, guys. And I'll send you a worksheet on this so you can practice some of these questions. But until then, I'll see you guys on Wednesday. Be safe. Have a good night.
You too, sir. Thank you.
Good night, sir.
Good night, sir.
Good night. Good night.